Okay, so today we're gonna do probability of dependent compound events. So going over what we did yesterday, compound events is an event that involves more than one possible outcome. Okay. So again, when, for example, rolling a die and flipping a coin, you can roll a die and see what the probability is of landing on a 6 and flipping a coin and the probability of landing on tails. Important thing to remember, when we see that word and, we're going to multiply. Okay, so yesterday independent events were events that were not affected by the previous one. Dependent events, though, are where refers to where the chances of one event does affect the chances of another event happening. So let's look at the next examples. Okay, so the first one says a bag contains 4 red marbles, 2 yellow marbles, and 1 blue marble. Stephanie is asked to pick 2 marbles at random from a brown paper bag. If she is to pick one at a time and is to put back each marble after picking it out. Find the probability that Stephanie picks out a blue marble and then a yellow marble. So a blue marble and then a yellow marble. Stephanie, so this, because she's putting them back, it means that we're going to do with replacement, which tells us that it is an independent event. Okay, so again, that does not change your possible outcomes. So for the first pick, we want the probability of blue. And for the second one, we want the probability of yellow. Before we can get the probabilities, we need to see how many marbles are inside of this bag. So you can either draw a picture or you can do math, right? So drawing a picture would look something like this, where you draw a box, a bag, whatever. You put in 4 marbles, 4 red marbles, 1 blue marble, and 2 yellow marbles. And here we can count them all together to see how many we have in total, which is 1, 2, 3, 4, 5, 6, 7. Or you could have done the 4 red, 2 yellow, and 1 blue, and add those all up, okay, which you would still get 7. So both of these, because she's putting them back, the marble back in, she's gonna do it out of 7. So out of 7, how many are blue? There's 1 blue. Okay, so 1 out of 7 chance of getting a blue. She puts that blue back in, so we still have the 7 marbles. And we need to see how many are yellow, and that's 2 out of 7. Okay. Because we have this word "and" here, we're going to multiply. So multiplying these together, we get 1 times 2 is 2, and 7 times 7 is 49. Okay. Here we look at if we can simplify. In this case, we cannot. Nothing goes into 2 and 49. So this stays the same. This is our final answer here. Okay, so now it's just time to write the claim. So the probability of getting a blue and yellow is 2 out of 49. Okay, so that's like the ones that we did yesterday. Those are independent events which do not affect the one before or the one after. Okay, this next one says it's the same example, but this time there is 2 red marbles, 4 green marbles, and 2 purple marbles. Okay, and Julian is asked to pick 2 marbles at random from a brown paper bag. He is to pick out 1 marble at a time and is to leave out each marble after he picks it out. So that means that this is without replacement, which means it is a dependent event. Okay. So we're going to find the probability that Julian picks out a red marble on both attempts. Okay. So now we have, we're going to do how many marbles there are in total. There's 2 red, 4 green, and 2 purple. Adding those up, I got 6, 7, 8 marbles. Okay, in total. So, first pick, we want the probability of a red. So P, red. Okay. Okay. In total, we had 8 marbles to start with. Bag is full. Okay. And out of those 8, there are 2 red. Okay. Let's say he took out that red. He got that red, he left it out. For the next one, the probability of another red. Now because he took out 1 marble, now there's only 7 marbles in the bag. Okay? And let's say he did take out that red. So then he's just left with 1 chance of getting a red. This is going to work the same way as the one before. When we see the word and, we're going to multiply. Okay? So we're going to multiply these 2 together. 1 times 2 is 2. 8 times 7 is 56. And this we can simplify by divided by 2. Okay? You guys can use your calculators, but this gets me to 1 over 28. Okay? This is our final answer for this one. Julian has a 1 in 28th chance. So the probability is 1 in 28. Okay, so there's a difference. With replacement, or when you put it back in, they're independent, you have the same amount of marbles. Without replacement, you leave it outside so it stays out and you have less marbles than what you started with. Okay, so last one. Example number 2 says, Kyan has created a 4-digit passcode for his new phone. He made it so that his new passcode does not have repeating digits. So that means we're going to do it without replacement. Yeah. So this is without replacement. Okay. The possible digits are 0 to 9, sorry. So how many numbers do we have in total? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 numbers in total. Okay. Find the probability that a random person would guess Kyan's passcode on the first try. So with numbers not repeating, that means once he uses one number, they're not going to use again, so it's without replacement. First digit. Doesn't matter what we say here, okay? But we know that it's going to be out of 10, okay? He chooses one of those numbers because each number only pops up once. Okay, let's say he used the number 5. That number 5 is now gone, okay? We cannot use that. So now in total, we have 9. Out of this 9, he chooses one number again. Let's say this time he got 3. They got 3, okay? And now that one's gone. So now for the third number, he only has 8 options. Let's say 8. Okay, these are just random numbers. And now he only has 7 options. And he chooses one. Okay, so because of this, we're gonna now multiply them all together. Okay. This is going to give them, so multiplying this all together, let's see my calculator right here. Okay, it was, well, 1 times 1 times 1 times 1 is 1 over, and then 10 times 9 times 8 times 7. That's 5,040. So the random person guessing his passcode correctly on the first try is 1 out of 5,040. Okay, so that's what our claim is going to be. The probability of pressing the passcode on the first try is 1 in 5,040. Okay, and there you go. That's how you do dependent events.